Hello, precious one. I welcome you once again into Kenya Mathematics Classroom. Today we are going to solve questions on matrices. But before we start to solve the questions, there are a few things I want you to take note. Now, there are a few things I want you to take note. So we are going to solve questions on matrices and linear transformations in general. So there are a few things I want you to take note. Now, the first thing I want you to take note is when you multiply, assuming that the matrix A equals A, B, C, D. When you multiply the matrix A by the inverse of A, it should give you the identity matrix or the unit matrix. And I guess by now you know what we call the unit matrix. So anytime you multiply a matrix by its inverse, you're supposed to get the unit matrix or the identity matrix. And so if A is the matrix A, B, C, D, you know how to find the inverse. The inverse of A is 1 over the determinant of A. Then you interchange the position of the first and the fourth element. So you have D here, you have A there, then you negate the second and the third element. So you have minus B, you have minus C. So when you multiply 1 over the determinant by D minus B minus CA, whatever you are getting is the inverse of that matrix. And so what we are saying is when you multiply a matrix by its inverse, it's supposed to give you the unit matrix. And you know that the 2 by 2 unit matrix is 1, 0, 0, 1. This is the 2 by 2 unit matrix. Now we are going to take a look at an example so that you understand what we are talking about. Assuming that we have the matrix A to be equal to 1, 2, 3, 4. Now we are saying that when you multiply a matrix by its inverse, you are supposed to get the unit matrix or the identity matrix. And the matrix you are given is 1, 2, 3, 4. That's a 2 by 2 matrix. So we first have to find the determinant of that matrix. And the determinant of the matrix is the first element times the fourth element minus the second element times the third element. So 1 times 4. Then we have 1 times 4 minus, then we have 2 times 3. So we have 2 times 3. And we know that 1 times 4 is 4. 2 times 3 is 6. So 4 minus 6 will give us minus 2. So the determinant of the matrix A equals minus 2. Now, if you are finding the inverse of this matrix, it will be 1 over the determinant. And the determinant is minus 2. Then we interchange the position of the first and the fourth element. So we bring the 4 here, the 1 there. So we have 4 here, we have 1 here. Then we negate the second element. Then we negate the third element. Then we simplify. Now, this is now multiplication of a scalar by a 2 by 2 matrix. And we said that anytime you are multiplying a scalar by a 2 by 2 matrix, the scalar multiplies all the elements of the matrix. So we have 1 on minus 2 is same as minus half. So minus half times 4, this will give us minus 2. Then minus half times minus 2 will give us 1. Then minus half times minus 3 will give us 3 on 2. The minus half times 1 will give us minus half. So this will be the inverse of the matrix. This will be the inverse of the matrix. And don't forget, we are now saying that when you multiply a matrix by its inverse, you are supposed to get the unit matrix. Now the unit matrix, the 2 by 2 unit matrix, you know is 1, 0, 0, 1. 1, 0, 0, 1. That's the 2 by 2 unit matrix. You have the ones along the principal diagonal. And so we are now going to multiply the matrix by the inverse we are getting to see what we are supposed to get. And so the matrix by its inverse, the matrix is 1, 2, 3, 4. So we have the matrix 1, 2, 3, 4 being multiplied by its inverse. And the inverse is minus 2. We have 1. We have 3 on 2. Then we have minus half. So now let's try to multiply to see what we are getting. Now when we multiply that, you take note, we are multiplying A by its inverse. And so when we do that, we have 1 times minus 2. It will give us minus 2. Then we have plus 2 times 3 on 2 will give us 3. Then we have 1 times 1. We are getting 1. Plus, then we have 2 times minus half. And that will give us minus 1. So we are done with the first row. Then 3 times minus 2 will give us minus 6. Then we have plus 4 times 3 on 2 will give us 6. Then 3 times 1 will give us 3. Plus 4 times minus half will give us minus 2. So if you simplify this, minus 2 plus 3 will give us 1. Then 1 plus minus 1 will give us 0. Then minus 6 plus 6 will give us 0. Then 3 plus minus 2 is the same as 3 minus 2, and the result is 1. So you see that we are getting the unit matrix. This is what I want you to take note. So anytime you multiply a matrix by its inverse, you are supposed to get the unit matrix or the identity matrix, and that is what you are seeing. So we were given the matrix A to be equal to 1, 2, 3, 4, and we are saying that when you multiply the matrix by its inverse, you are supposed to get the unit matrix or the identity matrix. And so before you find the inverse of a matrix, you need to find the determinant first. Now this is the matrix: 1, 2, 3, 4. The first element, second element, third element, and the fourth element. And so if you want to find the determinant, you multiply the first element by the fourth element. So we have 1 times 4 minus the second element times the third element. That is 2 times 3. So 1 times 4 will give us 4. Then 2 times 3 will give us 6. So 4 minus 6 will give us minus 2. So the determinant of the matrix A is minus 2. So if you want to find the inverse of A, we know that the inverse of A is 1 over the determinant. And the determinant gives us minus 2. So we have 1 over minus 2. Then we interchange the position of the first and the fourth element. So 4 goes here and the 1 comes down here. So that's how come we have 4 up there. Then we have 1 coming down here. Then we negate the second and the third element. And that's how come we have minus 2, minus 3. And now we have the scalar multiplying the 2 by 2 matrix. And anytime you have a scalar multiplying a matrix, the scalar will multiply all the elements of the matrix. And so 1 on minus 2 is the same as minus half. And minus half times 4 will give us minus 2. The reason is 2 goes into 4 2 times. And so we have minus 1 times 2, and that's why we are getting the minus 2. The minus half times minus 2 will also give us 1, because the negative will take care of the negative. And therefore, we have 1. Then minus half times minus 3 will give us 3 on 2. And minus half times 1 will also give us minus half. So now our inverse is minus 2, 1, 3 on 2, and minus half. Now what we are saying is when you multiply the matrix by its inverse, you are supposed to get the unit matrix. And this is the matrix 1, 2, 3, 4. And the inverse of the matrix is minus 2, 1, 3 on 2, minus half. So when we multiply, and I guess by now you know how to multiply two matrices together. Now we have 1 times minus 2, and that will be minus 2, plus 2 times 3 on 2 will give us plus 3. Then we have 1 times 1 will give us 1, plus 2 times minus half will give us minus 1. You can try it out in your own book and see what we are talking about. And that is why I advise you to get your book, get your calculator, get your pen, so that you can also practice what I am teaching you. Now 3 times minus 2 give us minus 6, plus 4 times 3 on 2 will give us 6. Then 3 times 1 will give us 3, plus 4 times minus half will give us minus 2. And so if you want to simplify, minus 2 plus 3 will give us 1. Then 1 plus minus 1 is the same as 1 minus 1, and that will give us 0. And minus 6 plus 6 will give us 0. Then 3 plus minus 2 is the same as 3 minus 2, and 3 minus 2 is 1. So you see that we are getting 1, 0, 0, 1. That is the 2 by 2 unit matrix. And so when you multiply a matrix by its inverse, it will always give you the unit matrix 1, 0, 0, 1. If it's a 3 by 3 matrix, then you will get the 3 by 3 unit matrix. So take note of that. It's very important. That's the first thing I want you to take note of. That's the first thing I want you to take note of. This is the first thing I want you to take note of. So now let's look at how we are going to look at how best we can use the matrix approach or the matrix inverse to solve for a simultaneous equation. That's the second thing I want you to take note of. Then when we are done with that, we will solve 1 or 2 questions, and that will be all on this platform. Now before that, let's assume that we are looking at how best we can use the inverse matrix. The inverse matrix to solve simultaneous equation. We are looking at how to use the inverse matrix to solve simultaneous equations. And so now let's assume that we have x plus y equals 5. We have x minus y equals 1. Assuming that these are the two equations we are given. Now, with these two equations, if you are supposed to solve the two equations simultaneously, we will use the elimination approach. That means that when we add the two equations together, we can find the value of x. If you want to understand simultaneous equation, when you refer to my video or presentation on simultaneous equation, you will understand what I'm really talking about here. To solve a simultaneous equation, you can either use the elimination approach, the substitution approach, or the graphical method to solve a simultaneous equation. Now we are going to use the elimination approach, and this is our equation 1, this is our equation 2. So we are going to add equation 1 to equation 2. And the reason why we are adding the two equations is when we add the two, we realize that we have plus y minus y, and the coefficients are all 1. So when we add the two equations, we can do away with the y so that we can find for the x. Then after getting for x, we now take it back into any of the equations, and the value of y will also come out. That's why we are doing that. Now, adding the two equations, we have x plus x. So we have x plus x here. Then we have minus y plus y. Then we have 1 plus 5. And x plus x will give us 2x. Minus y plus y will give us 0. So this is equal to 1 plus 5 will give us 6. And so now we are searching for x. And therefore we divide both sides by the constant attached to that variable that we are making the subject. So we divide this by 2, this by 2, and x will give us 3. So the value of x is 3. Now that we are getting x to be 3, then we can now put x to be 3 in any of the equations. Assuming we are putting x to be 3 in equation 1. Equation 1 says x plus y is equal to 5. Now x is 3, so 3 plus y is equal to 5. And y will be equal to 5 minus 3. 3 on the left hand side becomes minus 3 on the right hand side. And 5 minus 3 will give us 2. That means that the value of y is 2 and the value of x is 3. So when you solve this equation simultaneously, when you solve this simultaneous equation, the value of x is 3 and the value of y is 2. Now you can see that if x is 3 and y is 2, then 3 plus 2, you see that you are getting 5. If x is 3 and y is 2, then 3 minus 2, you see that you are getting 1. So this is the answer. Now we are going to look at how to use the inverse matrix, the matrix approach, to solve the same simultaneous equation. And so let's consider the equation again. We have x plus y is equal to 5. Then we have x minus y is equal to 1. So now we want to, because we are using the matrix approach to solve this, what we are going to do is you see that we have coefficient of the x term here is 1, and that will be the first element of the 2 by 2 matrix. Coefficient of the y term here is also 1. That of the x term here is 1. Coefficient of the y term here is minus 1. When we multiply this by xy, then we can also equate the constant. We have 5 and 1. Now we are trying to use the matrix approach. And that is why we are converting the simultaneous equation into the matrix form. And so now take note that when you multiply this by this and equate to this, you still get the same equation together. So now you still get the same equation. 1 times x will give us x, plus 1 times y will give us y. So you see that we have our x plus y. Then we have 1 times x will give us x. Then minus 1 times y will give us minus y. And this will be equal to 1. So when we multiply this by this, we are getting this back again. So that is how we are only trying to use the matrix approach. And that is why we are writing this in that form. So now, don't forget that we are searching for our x and y. And that's our x and y. But this is a 2 by 2 matrix. So we can say that let A be equal to the 2 by 2. 1, 1, 1 minus 1. If that's the case, then it means that we have A times x, y. This is equal to, we have 5, 1. Don't forget that the A is a 2 by 2 matrix. But now we are saying that instead of 1, 1, 1 minus 1, multiplying x, y equating to 5, 1, we say that A should be equal to the matrix. And so where you see the 2 by 2 matrix, that is why we have the A now multiplying the column matrix x, y, and this is equal to 5, 1. Now, take note of this. If you have 2x is equal to 4, and you're supposed to find the value of x. You have to divide both sides by the constant attached to the variable you are making the subject. So you divide here by 2, you divide here by 2. This is gone. X on the left will now be 2 into 4 is 2. So the value of x is 2. But what is really happening is this can be written as the inverse of 2 multiplied by 4. And this is the same as 2. What I'm trying to do here is now, if you have this, let's assume that we are searching for x and y. So obeying what we are seeing here, then we need to divide both sides by a. And when we divide both sides by a, we have only xy on the left hand side. But this a we are dividing by will now be the inverse of a multiplying 5, 1. The inverse of a multiplying 5, 1. That means that when the inverse of a is known, we can now multiply the inverse of a by 5, 1. That's the column matrix. And our x and y will be out. Now, the matrix A is 1, 1, 1 minus 1. So how do you find the inverse? You know that before we can find the inverse, the determinant must be calculated first. And so the determinant of the matrix A will be equal to, how do you find determinant? The first element times the fourth element. So 1 times minus 1. So we have 1 times minus 1. Then minus the second times the third element. That's 1 times 1. And this will be 1 times minus 1 is minus 1. Minus 1 times 1 is 1. So minus 1 minus 1. And that will give us minus 2. So it means that the determinant of A is minus 2. And therefore, the inverse of A will be 1 over minus 2. I guess you understand why. Because it's 1 over the determinant. Then we interchange the position of the first and the fourth element. So the minus 1 comes here and the 1 comes down here. So we have minus 1 up here. 1 will come down here. Then we negate the second and the third element. So this is minus 1, minus 1. Now let's simplify. This is now a scalar multiplying the 2 by 2 matrix. So the scalar will multiply all the elements. So minus half times minus 1 will give us a half. Then minus half times minus 1 will also give us half. Then minus half times minus 1 will also give us half. Then minus half times 1 will give us minus half. So this is the inverse of the matrix A. So now you know that we are saying that xy will be equal to the inverse of A times 5, 1. Now that we have gotten the inverse of A, we can now multiply the inverse of A by 5, 1. And we are getting our xy. I guess you understand what we are talking about. Now, let's look at this. Don't forget the equation is still up there, so I can take this off. But I guess you have not forgotten, because after solving the simultaneous equation, we had x to be equal to 3 and y to be equal to 2. So keep that. Now, the matrix here, we have it that x, y is equal to the inverse of A times 5, 1. And now the inverse of A is known. Half, half, half minus half. So we have half, half, half minus half being multiplied by 5, 1. And now, so this is our xy. So xy will be equal to, now this is a 2 by 2 matrix being multiplied by the column matrix. So it's half times 5, and that will give us 5 on 2, then plus half times 1 will give us half. Then half times 5 will give us 5 on 2, then plus this minus half times 1, and that will give us minus half. That will give us minus half. And so to simplify this, this is equal to, now 5 on 2 plus half is supposed to give us 6 on 2, and that is 3. And 5 on 2 plus minus half is the same as 5 on 2 minus half. And 5 on 2 minus half will be 4 over 2. And 4 divided by 2 will be equal to 2. So you can see that our xy is equal to 3, 2. So when you look at this, there is an equality between the two column matrices. And so the first element can be equated to the first element. The second element can also be equated to the second element. So you can say that x equals 3, that's x equals 3, and y is equal to 2. So you see that we are getting the same answer. That is what we had. We had x equals 3, y equals 2. So that's how we use the inverse matrix approach. That's how we use the matrix approach, the inverse matrix approach to solve simultaneous equation. And I guess you understand that And so these are the two things I want you to take note. Now we are going to solve. If you are not okay with what we have, I will advise that you take the video back, take your time, get your book, get your pen, get your calculator, and sit down and follow what I'm doing, and you will understand it better. If you also have any questions, you can send it to me in my Gmail account, right? nyako242@gmail.com. As far as mathematics is concerned, any question you send me in my email, I will answer it on this particular platform. And so that is how we use the inverse matrix approach to solve simultaneous equation. Now, let's continue. Now we are going to solve one or two questions, and that will be all on this particular episode. We are going to solve one or two questions on matrices. One or two questions on matrices. If you have not subscribed to the channel, I will advise that you subscribe to the channel, Kenyako Mathematics Classroom on YouTube. You press the notification bell so that anytime you release a presentation, you can have the alert. You can also share the video or the presentation so that someone can also benefit from it. Now, we are going to solve one or two questions. Now, the first question we are going to look at. This is the question. Now, if C equals -2, 5, 4, 3, and D equals 3, 1, -2, -3, we have to find the values of A and B such that, so we are given a condition such that DC equals 2 -3, 7, 2A plus B 4 -12 -3. Okay, so this is the question. This is the question you are given to solve. Now, the question we are given C, matrix C to be -2, 5, 4, 3, and matrix D to be equal to 3, 1, -2, -3. We have to find the values of A and B such that, now this is what we are given. DC equals 2 times -3, 7, 2A plus B4 -12 -3. Okay, now the DC here means we are supposed to multiply matrix D by matrix C. Then you equate to whatever we are given. Now, this is our matrix D and this is our matrix C. So let's multiply. Now let's attempt to solve. So we have DC equals 2 times, we have -3, we have 7, we have 2, we have A, plus we have B, we have 4, -12, then we have -3. And I guess by now you know how to multiply matrices together. So the matrix D from the question is 3, 1. 3, 1, -2, -3 times C. And the matrix C is -2, 5. We have 4, 3. And this is equal to, now, this is equal to 2. So when the scalar 2 is multiplying the matrix, it will multiply all the elements. So 2 times -3 will give us -6. 2 times 7, this will give us 21. 2 times 2 will give us 4 here. Then 2 times A will give us 2A here. Don't forget, it's plus. We have B, we have 4, -12, -3. Okay, so we now multiply. The left, we are multiplying this 2 by 2 matrix by the 2 by 2 matrix. And I guess by now you know how to multiply. So 3 times -2 plus 1 times 4. So let's start. 3 times -2 will give us -6, plus 1 times 4 will give us 4. 3 times 5 will give us 15, plus 1 times 3 will give us 3. The -2 times -2 will give us 4. Then plus -3 times 4 will give us -12. Okay, then -2 times 5 will give us -10. Then we have plus Minus 3 times 3 will give us minus 9. Okay, so this will be equal to, now let's simplify the right hand side. This is addition of matrix, and with addition of matrices we add the corresponding entries together. So minus 6 plus b, we have minus 6 plus b, then 21 plus 4, this will give us 25, then 4 plus minus 12, so it will be 4 minus 12, then we have 2a plus minus 3, and that will be 2a minus 3. Okay, so let's simplify the left. We have minus 6 plus 4, and minus 6 plus 4 will give us minus 2. 15 plus 3 will give us 18 here. Then 4 plus minus 12 is the same as 4 minus 12, and that will give us minus 8. Minus 10 plus minus 9 is the same as minus 10 minus 9, that is minus 19. And this will be equal to minus 6b. We have 25 here. We have 25 here. Okay, take note. Now let's look at this. Check the right hand side. You realize that this, okay, 2 times this, we were given this minus 3, 7, 2a. Okay, then this was b4 minus 12 minus 3. b4 minus 12 minus 3. Okay, so that's what we have there. So minus 6 plus b, right? Okay, then we have also 2 times 3. Take note that the 2 times 3 here was supposed to give us 14 rather, not 21. Okay, so 14 rather. I guess you understand that. Check it very well. Now we have 2 times minus 3, that's minus 6. 2 times 7 is 14, right? Okay, 2 times 2 is 4. Then 2 times 8 is 2a. That's right. So plus b4 minus 12 minus 3. Okay, so this is what we have. And so minus 6 plus b. We have minus 6 plus b here. Then we have 14 plus 4. Okay, so this is supposed to give us 18 rather. Okay, 18. Then we have 4 plus minus 12, and that is 4 minus 12. Okay, so we have 2a plus minus 3. That is 2a minus 3. That's right. So this is 18, not 25. It's 18. And I guess you understand what is happening. Take note that the right hand side, these two was multiplying all the terms. So 2 times minus 3 minus 6. 2 times 7 instead of 14, we wrote 21. It's rather 14. And 2 times 2 is 4. 2 times a is 2a. Okay, so we are done with that. Then 4 minus 12 will give us minus 8. Then we have 2a minus 3. Okay, so when you look at these two matrices, you realize that the first element, and this is minus 6 plus b, not minus 6b. Okay, so minus 6 plus b. That's right. Now you realize that the first element, because there is equality between the two, the first element can be equated to the first, the second, the third, and the fourth to 4. Realize that the second element 18 is the same second element 18 here. Then the third element minus 8 is the same element minus 8 here. So we can now equate minus 2. That's the first element. To the first element here, minus 6 plus b. And now when we look at this, we can group the constants on the left hand side so that we have b on the right hand side. So we have minus 2, minus 6 becomes plus 6 on the left hand side is equal to b. And minus 2 plus 6 is 4. So 4 equals b. Now what's really happening here is, if you want to do away with the minus 6, what we are saying is the minus 6 becomes plus 6 on the left hand side. The reason is that if you want to do away, what you do is you add plus 6 to both sides. When you add plus 6 to the right hand side, minus 6 plus 6 will be 0, so we'll be left with b. Then the minus 2 plus 6, then we have the 4. That is all. So now b is 4. Then we can also equate minus 19, that's the fourth element, to 2a minus 3. And let's group the constant also on the left hand side. So we have minus 19 minus 1 minus 3 becomes plus 3 on the left hand side, and this is equal to 2a. And minus 19 plus 3 is supposed to give us minus 16, and this is equal to 2a. So if you have minus 16 is equal to 2a, and you are making a the subject, then you have to divide both sides by 2. And this is gone, so that our a will be equal to 2 into 16 is 8 times. But remember that there is negative, so it means that a is equal to minus 8 and b is equal to 4. So from the question, you have to find the values of a and b such that bc equals 2 times that plus that. And now let me actually, I want to go over so that you understand what we have here. These were the matrices we were given. Matrix C was equal to minus 2, 5, 4, 3. and the matrix D was equal to 3, 1, minus 2, minus 3. We have to find the values of A and B such that this is the condition we are given. We are given the condition that DC is equal to 2 times minus 3, 7, 2A, plus B, 4, minus 12, minus 3. So that's what we have there. Now, D has been given to this matrix, and C has been given to that matrix. So DC means multiply. Then you equate to what we were given. Now, this is the scalar multiplying this matrix. So 2 times minus 3 minus 6, 2 times 7, 14, 2 times 2 is 4, then 2 times A is 2A, then plus we have B4 minus 12 minus 3. Okay, so then now we multiply this 2 by 2 matrix on the left hand side. So it's 3 times minus 2, that's minus 6, plus 1 times 4 is 4. 3 times 5 is 15, plus 1 times 3 is 3. Minus 2 times minus 2 is 4, plus minus 3 times 4 is minus 12. Minus 2 times 5 is 10. Minus 2 times 5 is minus 10, plus minus 3 times 3 is minus 9. And this is equal to, now this is addition of matrices. So we add the corresponding entries together. So minus 6 plus B, 14 plus 4, 4 plus minus 12, and 2A plus minus 3. And so this is what we have. Now minus 6 plus 4 is minus 2. 15 plus 3 is 18. 4 plus minus 12 is the same as 4 minus 12, and that is minus 8. And minus 10 plus minus 9 is the same as minus 10 minus 9, that is minus 19. So when we simplify the right, we have minus 6 plus B, 18, 4 minus 12 will give us minus 8. Then we have 2A minus 3. So now the equality exists between these 2 by 2 matrices. And so two matrices are said to be equal if their corresponding entries are the same. That means that the first element can be equated to the first element, second element can be equated to second, third element can be equated to third element, and the fourth element can also be equated to the fourth element. And so if we equate the minus 2 to minus 6 plus B, then we have minus 2 equals minus 6 plus B. Then we need to make B the subject. So we group the constant on the left hand side. That's how come minus 6 became plus 6 on the left hand side. And I guess I've explained this. You know why it's plus 6. So minus 2 plus 6 will give us 4. So we have 4 equals B. That means B is equal to 4. Then we can also equate the fourth element, minus 19, to the fourth element. So minus 19 equals 2A minus 3. We group the constant on the left hand side. We have minus 19 plus 3. The minus 3 also becomes plus 3 on the left hand side. The reason is that we are adding 3 to the right hand side. And whatever we do to the right hand side, we have to do the same thing to the left hand side. So when we add plus 3, minus 3 plus 3 will be 0. So we will be left with 2A. That's what we have here. And the plus 3 is what the plus 3 we have here. So minus 19 plus 3 will give us minus 16. And this is equal to 2A. If minus 16 equals 2A and we are making A the subject, then we need to divide both sides by the constant attached to the variable we are making the subject. So we divide both sides by 2, both sides by 2. And when we divide 2A by 2, 2 cancels 2 and we are left with A. And 2 goes into 16 8 times. Because of the negative, we have minus 8. So minus 8 equals A. So A equals minus 8 and B equals 4. So that is the solution to this question. And that will be all for now on this episode. Thank you.